Hi, everyone, and welcome. Thank you for joining us. So as Kimberly said, my name is Tom. I look after the customer success team here at ROEST. And today I'm going to be showing you around our flagship sample roaster, the L100 Plus. So this is a professional sample roaster, and it's designed around the idea that automation can make your working life easier, and it can also improve the quality of your roasts. And this is a beautiful but very powerful little machine. It can roast up to 200 grams of coffee at a time. And if you want to, you can roast those batches back to back all day long, which means that you can be doing the best part of 2 kilos of roasted samples every hour. And the best part about all of this is that you can do all of this with minimal intervention. So you can just set a profile and then let the machine take care of the rest. And that really frees up your time to work on other things. All you have to do is load the coffee. The machine will follow the roast profile that you've set. It'll mark the phases of the roast automatically. It'll drop the coffee for you based on the criteria that you choose. And then all you have to do is to collect the roasted coffee at the end. And because of that, we think this is pretty much the fastest and most efficient sample roaster that you can get. So first of all, I just want to take a look at these machines and show you what the different parts are. So you can see, first of all, that we have 2 different finishes here. You can choose wood side panels or these in black aluminium. And we build these machines right here in Oslo, in Norway. And that means we can keep really tight control over the quality of the build and, of course, of the materials as well. And if you look on the front of these machines, you can see that although they're sample roasters, we have a sight glass and we have a little trier, just like on a commercial machine. And so this means that if you want to, although this machine is designed around automation, if you want to, you can roast the old-fashioned way by sight and by smell. So then on the front, we have a touch screen, and then this knob on the top is for changing the parameters of the roaster and for taking manual control. And then I mentioned that it has a 200-gram capacity. So actually, all of our Plus series, so the S100 Plus and the L100 Plus roasters can all roast 200 grams. And if you do want to roast 200-gram batches, then all you need is to get hold of our hopper extension and the larger cooling tray so that you can fit those bigger batches in. And if you have an older machine or if you have the S100 model, then you can upgrade by installing the inlet temperature sensor. And that kit will then enable you to roast 200 grams on your machine as well. Then at the back of the machine, there's a miniature cyclone built into the machine. So that's separating the chaff and the dust from the exhaust gases. And that chaff collects under here. Behind here, there's a drawer that collects the chaff. And that means you don't have to stop after every single batch, clean out the chaff, restart the roaster, and start again. Instead, you can just empty this drawer every 20, 25 batches or so, which makes your workflow much faster and much more efficient. And then finally, for installation, it's very easy with this machine. So it draws about 1.6 kilowatts at maximum. So that means you can use a standard socket. You can plug it in, whether you're on 230 volts, 110 volts like in the US, or 100 volts like in Japan. You can just plug it into a standard socket. It doesn't need any special electrical installation. And then for the exhaust, it comes with a flexible hose, and you can connect the exhaust of the machine to your ventilation system. You can point the hose out of the window. Or if you don't have easy access to ventilation, and if you're not near the window, but as long as your space is well ventilated, then you can just attach a 90-degree attachment that will allow you to roast without any ventilation attachment at all. And all that does is just points the exhaust gases away from the machine in whichever direction you choose. So it's super flexible and easy to install. It means you can put it into a lot of different kinds of spaces. Okay, so what I want to do is show you just how easy it is to roast. So I have 100 grams of green coffee here. I'm going to load it up. Oops. And then all I need to do is charge the batch. And at this point, I can relax. Very dusty coffee here. But at this point, I can relax. I don't need to do anything else. The roaster is going to take care of the rest of the process for me. So right now, it's following the profile that I've set. It'll mark the stages of the roast. It'll mark first crack based on the sound. So as soon as it hears pop, it'll mark first crack. After that point, it will count down the development time that I've chosen, which is 47 seconds today, and then it'll drop the batch. So if I don't do anything else, it'll just finish that roast for me with no more intervention needed. And this means I can be spending this time maybe setting up a cupping or maybe roasting on my production roaster at the same time. So it really frees you up, or even just relaxing and drinking a coffee if that's what you need at this time of day, because I know I do. But while this is roasting, I want to talk you through a little bit of how this machine works. So it is a stirred drum roaster. And so what that means is we have a drum here in the middle of the machine where the beans are. But instead of the whole drum turning, there are paddles that are turning and they are mixing and lifting the beans. Meanwhile, we're blowing hot air into the drum from this side. And that hot air that we're blowing into the drum is the only heat source. So this is a convection-based roaster. The only heat is coming from hot air. And convection allows you to heat beans very quickly and very evenly without any risk of burning the surface of the beans that you sometimes get with conduction. If you have a hot drum, then you can get excessive conduction, and that can sometimes lead to defects like scorching or facing where the surface of the beans is getting burned. And to understand why, think about how an oven works. If you have a hot oven, let's say it's at 200 degrees C, and you put your hand in the oven, you can feel the heat of the air, but your hand doesn't burn. But as soon as you touch the metal surface inside the oven, you burn yourself. So the convection from the air isn't burning your hand, but it's heating your hand evenly. But as soon as you touch the metal surface, then you get burned. And it's the same for our beans. If they're in the hot air, they're not burning, they're just heating evenly, and that allows us to roast very fast. But if you have a hot drum, as you do on kind of conventional roasters, then that drum surface, if that drum surface gets too hot, you can burn your beans. So that's why we love convection. And while we're roasting, the machine is collecting temperature data from 5 different points in the roaster. So we have a temperature sensor here measuring the inlet. So that's the air just before it reaches the drum. So that's a measure of the total amount of heat that we're putting into the drum. Then we have a bean temperature sensor here in the middle of the bean pile. So that's giving us good bean temperature data. On the opposite side, we have another sensor on the opposite side of the drum measuring the air around the bean. So that's like your environmental temperature inside the drum. And then one here at the drum exit. So that's measuring the temperature of the air as it leaves the drum. And then finally, we have one, a pretty unusual one, which is on the drum surface itself. So we're monitoring actually the temperature of the drum surface and getting an idea of the thermal energy of the machine itself. And you can watch the data from all of these probes in real time. This machine is connected to our servers by Wi-Fi. And that means you can be looking at this data from anywhere in the world. And to do that, you just log into our web portal and you can see this roast happening in real time. So I'm going to switch over to that screen so I can show you that now. Give me 1 second. Okay, so this is our live view. So this is the curves from all of the temperature sensors that I just described in the roaster. So that green line at the top is the inlet temperature. So that's the temperature of the air blowing in. The blue and the gray lines beneath it are the air inside the drum and the exhaust. Those 2 red lines are, of course, the bean temperature and the rate of rise. And then finally, at the bottom, you can see the purple line. That is the drum surface temperature. So you can see already that the drum surface is cooler than the beans. So we're not getting significant conduction in this machine. It's all convection based. And then finally, down the bottom here, you can see the fan setting and the drum speed. And then the gray line is the power. And you can see the machine is automatically adjusting the power in order to stay on our profile. And the profile is that dashed green line. It's the inlet temperature profile we're following. So if I don't do anything else, the machine will continue adjusting the temperature to follow that dashed green line. It'll mark first crack. And once it hears first crack, it'll count 47 seconds. So that's the development time that I've set. And then it will drop the batch. If I want to, I can take control at any time. So if I grab the power setting and make a change, now I'm in manual mode. And at this point, I have full control over the roaster. I can control the power, the fan speed, the drum speed. And you can see when I make a change, the effect of that is very, very fast in the live view. So you can see where I made the change here, I made a small drop in power, and the inlet temperature is already going down rapidly. So when you make a change, you feel the effects of that change very quickly. And that's partly because we're using a lot of airflow and powerful heating elements, but it's also because we use very fast responsive temperature probes. So the temperature reading that you get is very up to date. You get a very accurate current reading, and that makes it really pleasurable to roast on. But I can go back to automatic mode at any time. So I'm going to do that now. So now the machine will go back to following the profile. And you can see that we're now into first crack. So you probably can't hear it, but I can hear the pops of first crack right now. And I can see that the machine is hearing those pops too. These orange lines on the graph down the bottom represent every single crack that the roaster has heard. So it's marked not only the moment of first crack, but you can also see how many cracks there are, how intense first crack is, whether it's spread out or not. The machine is now counting down the development time, and when it reaches the end, it's going to drop the batch. So it's dropped the batch based on the development time I chose, and then as soon as this door closes, I can start roasting the next batch right away. So I could load my green beans right now, start roasting the next batch. So in terms of throughput, you really can go back to back. That makes it much, much faster and more efficient than any other automatic roaster that we know of. Meanwhile, this batch can be cooling while you're roasting the next one, and it will be cool in about 90 seconds. The reason we get so excited about this first crack detection is because it allows you, with a single profile, to roast different coffees and still get decent results. So, for example, if I load if you've got a mountain of samples, you don't want to spend a lot of time changing profile for each one, watching every single roast like a hawk. With the first crack detection, if you load a smaller bean, those beans tend to heat up more quickly. They reach first crack earlier, and the machine hears that they reach first crack early. And so it shortens the roast time, so those beans don't get over roasted. Then maybe the next sample you throw in is something a bit bigger, a bit denser. It needs more heat to reach first crack. Well, the machine hears that first crack is later, so it extends the roast time to extend that development so that you still have a good roast on those beans as well. So using this allows you to adapt to the different kinds of beans that you're roasting, which is really, really useful. Okay. Now, let me see. Oh, yeah. So now the machine is idling. But if you want to, you can also set a between batch protocol to start automatically. So when one batch ends, you can set the machine to follow an automatic profile that will cool down or maintain the heat of the machine in the way that you set. So if you like to cool the machine between batches, you can set this to do it automatically. It'll go straight into your between batch profile. And then when it reaches the target drum temperature, it will alert you that you're ready to charge the next batch. So if you want that kind of precision where you charge every batch with the same amount of thermal energy, you can do that, and it's not guesswork. Instead, you actually measure thermal energy in the machine by measuring the drum temperature. So that's really, really useful, especially if you're roasting the same coffee back to back. You can get absolutely identical results this way. Okay. So now I'm going to set the machine to cool because we're done with the roasting. And I want to show you a few of the other things that we can do in the web portal. So first thing I want to show you is that when I exit the full screen, you can see that this app is browser-based. So that means you can be using this on any device that's connected to the internet. So I have it here on my laptop. You can run it on a tablet, on your phone, whatever you have, and you can be watching this data, or you have access to this data from anywhere in the world. So if you're out traveling, buying green coffee, and you want to go back and check, I remember this coffee last year, how did it roast? Or what are the guys back in the lab doing while I'm here? You can go in and have access to all of that data in real time. I'm going to show you the profiles next. So this is where we set and edit the profiles that the machine is following. This profile here, the 100-gram sample profile, is the one that I had loaded up today. The profile tells the machine how to control the temperatures or the power during the roast, how to control the fan speed, and how to control the drum speed. If you want to change it, very easy to just click and drag points around the graph and modify the amount of heat. Same with the fan speed or the drum speed. I can double tap to add a point, drag that point, and now I'm telling the machine, okay, increase the fan speed during roasting and then decrease it again. So setting up a profile is very easy and intuitive. Then over here on the left, part of the profile, you can tell it how to preheat the machine, so what temperature to preheat to, and then you can choose how to end the batch. So I've chosen a fixed development time. This was 47 seconds, but you can choose a percentage if you prefer. If you want to control your development time ratio to be the same every time, you can choose a percentage, or you can choose a target bean temperature to end the batch at, or you can opt to end it manually. So you have some flexibility there as well. Next, I want to show you the logs. So in the log view, you have access to every single batch that this machine has ever roasted. So you can always go back and see how previous batches went. You can compare batches against each other, which is really useful for QCing your roasting or understanding the way the different coffees behave at the same roast profile. So if I load it up, I can look at the roast we've just done. From this view, it's very easy to now replicate this. I can turn this back into a new profile. So I did this little change at the end in manual. I can convert this to a new profile. Now I have a profile that will replicate exactly the roast that we just did. Then over here, if creating your own profile feels a bit too much like hard work for you, you can start with the profile library. So this is a public library of profiles that have been shared by other users. So if you are new to roasting, or if you want a bit of inspiration, you can borrow profiles from people like Tim Wendelboe, from Nordic Approach, from Christopher Ferran, really from anyone that has shared their profile in here. So there's some really good starting points for your own roasting in here. And of course, you can share your own with other people as well. And over on the left, we have the inventory management system. Now this is empty because I'm in a demo account, so it's not actually linked to our green coffee here. But you can use this to track how much of each green coffee you have, keep track of the QC data, things like moisture content, density, those kind of things, and link it to your cupping scores. And then, of course, we have the cupping app. So here you can set up a cupping of the different roasts that you've done. You can invite your team members to join, and they can scan a QR code on their phone. And then there's a really nice, simplified interface for them to enter their scores on their phones while they're cupping. And then it will average those scores together and link that to your roast profile and to your inventory as well. So you do have a full featured roasting management system in the back end here if you want to use it, even though this is just sample roaster. Okay. So that is everything in the live view that I want to show you. I'm going to stop sharing my screen. And then before we wrap up, I just want to talk a bit about the kind of cleaning, maintenance, and support side of things. So first of all, the end of day cleaning, it's very simple. You just need to clean out the ventilation briefly, empty the chaff, of course, and clean out the filter beneath the bean cooler. And that's it on a daily basis. Every few thousand batches, or perhaps every year or so, it's a good idea to do a deeper clean. And for that, you can open up the machine, disassemble the cyclone, and really get in there. The machine is designed from the ground up to be easy to access, easy to get inside. It's an open design. And the idea behind this is that if you do need to do any maintenance, if anything does need any repair, or if you want to upgrade your machine, it's something you can do yourself. The machine is designed to be easy to open, easy to access, and easy to do these kind of fixes yourself. And what this means is if something happens to your machine, you don't need to call out an engineer, wait for them to come and be down for that whole time. You don't need to ship this machine back to Norway, get it through customs, wait for us to do that repair for you. You can tackle it yourself, and we are here to help you with that process. So me and Joe in the customer service team, we are helping customers every day with carrying out these kind of repairs, and it is designed to be as quick and easy as possible. Of course, you can hire somebody to do this work for you if you want. You always have access to parts and support from us in Norway, but we are also growing our network of partners around the world so that you have local access to parts and support as well. And the other thing about this, as well as making your maintenance easier and faster, and of course a lot cheaper if you're doing it yourself, the other advantage is that it means whenever we develop new features, as much as possible, we design them so that they can be retrofitted into existing machines. So we design them to fit onto mounting points that already exist. We design them to fit into machines that are already out there. And what this means is if we develop something new, because we are always working on these machines, whenever we develop something new, if we possibly can, redesign it so that if you already have a machine, you can get that upgrade, you can install it in your own machine, and you can stay up to date with the latest features. And for us, this is really about sustainability. It's about making this a machine for life. It shouldn't ever get to the point where it can't be repaired or it can't be up to date. As much as possible, we try and keep it so that these machines stay relevant no matter when you bought them. So yeah, so that's it about the support and maintenance side of things. And yeah, I hope that I've shown you today a little bit about how much easier having a machine like this as a tool can make your life. If you've got a mountain of samples to get through, that level of automation and the precision that it has lets you get through those samples quicker than any other sample roaster that we know of. So with less work and in less time. But it also, at the same time, as well as being automated, it has really precise, consistent results and very tight control over the roasting parameters. So you can also use it to roast your coffee down to whatever level of specificity you choose. If you have competition coffees that you want to give really special attention to, you can do that as well. Or if you just have a mountain of samples to bash through, you can do that and make it simple. You can make it as simple or as complicated for yourself if you like. And most of all, I don't know a sample roaster that can keep up with this in terms of the sheer throughput, in terms of the number of batches you can get through compared to the amount of work you need to put in. So that is why we think it is the fastest and most efficient sample roaster that you can get. That's everything I wanted to present today, but we've left plenty of time for Q&A. So I'm going to pass you back to Kimberly. She's going to help me with some of your questions.
Hello, I'm back. Thank you very much, Tom, for that demonstration. That was super helpful. Thank you. Okay, so we are taking your questions. If you want to just pop them in the chat, we will answer those for you. I can already see some coming in, so get those in that chat box and we'll address them. We'll start off with a question that came in from the RSVPs. Is the sample roaster just for sampling and cupping?
Okay, so it is designed as a sample roaster first and foremost, and you can see that in a lot of the features we've chosen. But we have plenty of users that have it for other purposes. So of course we have a good chunk of our users are home roasters. So it's a easy to install in your home. It's a beautiful machine. You can roast small batches. It makes a great home roaster. And if you are roasting at home with this machine, it's an amazing way to learn about the roasting process because you have so much insight into what's happening in the coffee. With that temperature data, you can really see how the beans respond to heat and how the way the beans absorb that heat changes by seeing how the air temperatures change across the room. And so it's really nice for that. We have plenty of people who also use it for very small scale production, whether that's because they're just starting out with roasting or maybe bigger, more established roasteries use it for their competition lots. So if you just need 1 or 2 kilos of something really, really special, you can't put that in your production roaster, of course. So you rely on a roaster like this. You do 5 200-gram batches, that's a kilo of coffee. And if you get the profile right, then you can replicate it 5 times, get exactly the same results. So that you then have a kilo of perfectly roasted coffee. Competitors who've done that include people like Tom Hutchins, who was the Australian Brewers Cup champion this year. He was using that in the World Finals in Chicago. Yeah, so there's more you can do with it, but samples is the focus.
Great, thank you. So the next question is, do you change profiles based on the origin, density, moisture characteristics of the coffee, or should you use the same profile for all of your coffees?
Yeah, so this is kind of a philosophical question, and I would say there are a lot of different valid approaches here. So we have some customers who are green coffee buyers, let's say, and they need to roast hundreds and hundreds of samples. They don't have time to be really making minor changes to whatever profile they're using. And I think in that sort of case, it's perfectly rational to use a single profile. And you can use features like the first cut detection, and there are other features as well that let you adapt that profile a little bit to the beans that you put in without adding any extra work. So if you get a good profile designed, pick the right development time, and then roast a ton of different coffees on one profile, I think that's completely valid. And that's probably the fastest way to get through a huge number of samples. But then on the other extreme, we have people who insist on roasting every batch manually, or at least finishing every batch manually. So you can start in automatic mode, maybe the first 2/3 of the roast you think don't matter that much, but around first crack, you take over and you finish in manual. So then every single batch is getting that kind of hands-on attention, and then everything in between. I'd say the most common approach is for people to have maybe 3, 4, 5 profiles, one for washed, one for natural, one for tiny beans, maybe one for big beans, and one for weird processes. Something like that will cover most of your use cases. But if you decide that actually one profile is the way to go, I think that's completely valid. If you decide you want to roast every coffee manually, more power to you.
So you showed us in the web portal that there's a profile library that had profiles that other users have put out there. So there's the Nordic approach standard, which they will use to cup all their coffee samples, for example. So you can use one profile, and that is one that a green importer does use. So if you go into the profile library, you can download to your machine and then roast on that. I know I've used it because I'm not a roaster. I'm very much still learning. So I've tried Tim Wunderbo's profile, I've tried roasts, and I've tried Nordic approach. And then I've cupped the coffee just to see what difference there are. And is there, do I have a preference for a specific coffee that I've got? So it's a good starting point. But talking about designing profiles, you explained that we were using an inlet temperature for today. Could you show us how to create a new profile from scratch and the different types of profiles that we can create in the web portal?
Yeah, sure thing. And I can see also that Valerian was asking about a bean curve profile. So I'm going to cover that as well. So I will share my screen again. Give me 1 second. Okay. So for me, the easiest way to start is with an existing roast or an existing profile. So I think I showed you already that if you start with a log of a roast that you think was successful, pick it up, convert that into a profile, and then you can choose an air temperature profile, a bean temperature profile, an inlet profile, or a power profile. And all of those will give equivalent results. But the idea is you're telling the machine which of those things you want to base it on, and it will do its best to copy exactly what just happened in that roast. So for me, if I'm trying to create a profile for a coffee that I don't know before, I might just start out by roasting it manually. And if I'm happy with the manual roast, I'll then turn that manual roast into a profile. So if we imagine that this roast was a manual roast, I mean, we know it wasn't, but pretend that it was, I can then say to the machine, okay, love this roast, let's do it again, copy it. And you can choose to copy the exact power settings that the machine had during the roast. You can choose you can set it to copy the inlet temperature that resulted from those power settings. Or you can say, okay, this is my bean curve, make it follow this bean curve. So the answer, Valerian, to your question is yes, you can set a bean curve. Now, the difficulty with this is if your beans respond to heat very differently, then this curve may not be appropriate to a different coffee. So this kind of curve will work great if I'm roasting the same coffee again. If I then go and roast a different coffee with this bean curve, it may not give me the results that I'm looking for. So you can create this kind of profile, but I would say approach with caution. So my preferred type of profile to create is an inlet temperature profile. So again, I would start with the log, convert it to profile, choose inlet temperature, and make this profile pretty much following the roast that I've just done. But then the question was, what about if you start from scratch? Okay, so if I go back to my profile screen and go create new profile, again, I have options of different kinds of profiles. There's some here we didn't talk about, the bean inlet temperature and the bean power profile. I'm not going to go into those now because they're a bit complicated. That's probably something for a future webinar. But right now, I'm going to pick inlet temperature And you can see this is what a blank profile looks like. So just a flat line for inlet, flat line for fan speed, flat line for drum speed. So if I already have an idea of what I want this profile to look like, I can double click to create a point. I can drag it to where I want it. I can build up my curve this way. And if I want to make small changes, here I can edit the specific temperature or the specific time to get it exactly where I want it to be. But if I'm starting, again, if I'm starting from scratch and I want an automated way to roast a coffee that I know nothing about, to be honest, my favorite approach to begin with is just to do a flat inlet temperature. Sounds super, I mean, it is super simplistic, but it can get surprisingly good results. And it's also a way that a lot of commercial coffee is roasted with just a single inlet temperature. So I'm going to delete these extra points. What I would do is maybe set a 300 degrees inlet temperature at the beginning, 300 degrees at the end. And that's it. This profile will already roast decent coffee. If I adjust the development time, then I have access to quite a wide range of flavors just by tweaking the development time. So if you're just starting out in roasting, you want an easy life, set a flat inlet temperature, experiment with the development time. And with just that one lever, you have access to something like 80% of the potential, the flavor potential of your coffee in terms of how much you can change the way that that tastes. If you want to explore the next kind of level of flavor possibilities, then you can just try different flat temperatures. Try 320, try 280, and adjust the development time. And in this way, you can be exploring the flavor potential of a coffee without complicated profiling. The complicated profiling is something to go into as you become more comfortable with the machine. But you, like I always say, if you want to make it simple, you can, and you can get really good results this way.
Thank you. So another very popular question that we receive is, can you transfer profiles from the sample roaster to a production roaster?
Yeah. We get this question all the time, and I'm afraid the answer is basically no. Every roaster is different in terms of its heat transfer characteristics, in terms of the size, the amount of energy it has available, the way the beans move inside the roaster. There's so many different variables. So there's no way to directly transfer from one machine to another, not any two machines. But if you are thinking about using a sample roaster for profiling, in other words, you want to try and understand how a coffee behaves in a roaster, how it's going to taste best in your production roaster, then this is, I would say, as good as a tool as you can get for doing so. And there's two reasons for that. One is you have a ton of information about how the coffee behaves during roasting. So you have, with the 5 temperature sensors, you can see not only how the beans responded to heat, but also how much of that heat they were absorbing from the air as they passed through. You can see how the thermal energy of the machine affected the roast. So you have, and you can also look at the first crack data, so you can see if early cracks have any effect on the roast, if the crack intensity has any effect on the way the beans respond. All those kind of things give you a lot of information about how that coffee is behaving in the roaster, and you can use that knowledge then to go and build your profile in your main machine. But the other thing that it allows, because of the automation, it makes it really, really easy to make small changes and test them out. And like I was saying before, like to explore the flavor space of a coffee. So to know how good that coffee could taste, so that you then have something to aim for. So you could set up your standard profile and just try 3, 4, 5 different development times, and then maybe your standard profile, but a bit faster, a bit hotter, and a few different development times. And you start to create a map of the potential of the coffee. And then you can say, okay, with this coffee, I liked it a bit hotter than usual, but with a bit less development than usual. And that is something you can then apply onto your typical profile on your production roaster. But you can't just take one curve and put it on another roaster, because that will never give you the same results, but you can take the learnings from one and transfer it to the other. The only thing that I would say is if you are thinking about our production roaster, the P3000, because that is built along similar principles, there are some similarities in how those two roasters behave. They're still not the same. You still can't take one profile and put it on the other, but we hope that, or rather we will be developing a tool that will allow you to, that will guide you to creating a profile from one that will give you similar results to what you have on the phone. Never going to be exactly one-to-one, but because we know about the heat transfer in these two machines, we will be able to give you at least some guidance to make that process easier.
Yes, and we have explored this particular question in our last couple of blog posts. So I've just dropped some links in the chat to a two-part article on sample roasting to production roasting. So in there is a great exercise which Tom was sharing about flavor exploration. So it's actually something that I've tried myself. I've got a washed Brazilian micro lot that I bought, and I just tweaked the development time by 5 seconds between the batches. And my palate may not be as developed as some, but I can taste a little bit of difference. And that was just basically using the same roasting profile and changing the development time by those 5 seconds. So as someone who's very new to roasting, this was very easy for me to explore how to roast and what small changes can affect the end result in the cup. So there are a couple of links there. You will be able to find them on the blog, and try it out. Let us know, see how that information may have helped you with that transferring of curves between machines. Let's see what other questions have we got here. There's a question here from Valerian. Did you do a batch-to-batch color consistency test on the same profile? I assume that the first crack can shift a tiny bit from roast to roast.
The first crack can shift. Yeah, it can shift a tiny bit. It's how consistent it is depends a bit on how you design your profiles and how you design your between batch protocols. In terms of color reading, it's a little tricky with the sample roaster because our color reader needs a good amount of copy. So I haven't done as much comparison of color readings as with this one as I have on the production roaster. So I'm not really confident putting a number on it. But I can say the consistency is good. And if you put two batches side by side in terms of the temperature curves, if you've managed your thermal energy, if you've managed your drum temperature, then those curves will trace each other exactly. So from that point of view, we're very confident about the consistency in the machine.
Great, thank you. Then we have a question about the cupping form. So are you able to make custom cupping form templates? And if not, is there a feature that will be added?
So yeah, at the moment, this doesn't exist. It is something that is, let's say, on our minds. Right now, our development focus is on the firmware for P3000 and the software around that. But we do have plans to improve the functionality of the inventory management and the cupping software. And this is definitely one of the things that I've already is in our list of requests. But at this point, I can't say when that is going to be implemented.
So here at ROEST, we take our customer feedback to our teams, and we implement them where we can and where it makes sense for our products. So a lot of our customers have been on our journey for the last 10 years. And because of their feedback, because there's their testing and putting our products through rigorous roasting sessions, we are able to improve the machine. So any feedback that our customers provide us, we will take on board. So if you have ideas, if you have some issues that you think could be resolved a certain way, we are always welcome to that. I know Tom gets a lot of information from someone's experience, and then we take that forward as we continue to develop our products. So
yeah, and a lot of the most important features have come out of that customer feedback. So the inlet temperature wasn't in the initial roasts, and it's something that we developed in response to really not even a huge number of customer requests, but enough people asked, and we thought this sounds smart. So we did it, and it's now my favorite way to roast on this machine. So we really do listen to those requests. So keep them coming, and we are always working on it.
There's a question here in the chat from Robert that says, how many hours can you roast in a day on this machine?
How many hours can you stand up is pretty much the answer to that question. There is no daily limit. So as many batches as you can manage, the machine will keep up with you. The only times you have to stop, like I said, every 20, 25 batches, you need to empty the chaff. And to do that, really, you should cool the machine at least enough so that the inlet, so that the heating element has cooled down, ideally so that the drum is cool. Turn it off, and then pull out the chaff drawer. I'm just showing you this now because I can. So this is where the chaff collects. So every 20, 25 roasts, you'll need to empty this. But then you can put it back in, start roasting straight away. And apart from that, there's no reason that you would need to stop. It doesn't need any rest time. It can go as long as you can.
We definitely recommend that you are by the machine for health and safety reasons. But yes, Valerian, you can sit. It's not a requirement to stand and roast all day. This machine has got a small footprint, so you are able to have it on a countertop, in the lab or at home. I have it on my kitchen counter, and I've got a little bar stool that I sit on so I can actually watch the live view on my laptop whilst I sit there with the machine and roast. But also know that my coffee machine is just on the other side of the room, so I can just pop over there and make my coffee. So yes, is the answer.
Leave it unattended. Apart from that, you can keep going.
Right. If there's any other questions, we still have a few more minutes. Just pop them in the chat there. There's a question here from Chase, which is, are you planning to add any moisture release sensors?
This one is a little bit controversial, but essentially the answer is no. We're not planning to do any moisture release. And the main purpose of the moisture release sensor that has probably inspired this question is for detection of first crack. And since we already have a working first crack detection based on audio, it's not really something that we think adds any value to what we have already in this machine. And for me, marking first crack based on audio is a lot closer to what we as humans do. So if you're marking first crack on your production roaster, if you can hear it, you're marking it based on the sound. If you can't hear it, you're marking it based on the temperature. So the machine marking it based on sound is much closer to when you would, as a human, mark first crack. Marking it based on moisture release does mark it at a slightly different time, and what those sensors, there's some question marks in our minds about what those sensors are actually measuring. They do work well, but we don't think it's going to add anything useful in terms of the information we have about roasting, because we already have that feature in terms of the detection.
Thank you. Okay, so it looks like we've covered all the questions in the chat. We are here as ever.
Sorry, KD, there was one from Valerian that I noticed that we skipped over, asking about the ratio of convection to conduction. But unfortunately, I don't have a really nice answer for you on this one because it is a convection-based roaster. So yes, you probably can slightly manipulate the amount of conduction by changing the temperatures or changing the RPM, but it's very, very difficult for us to, it's a very difficult thing to measure, an impossible thing to measure. So I can't really say how doing that exactly affects the ratio. And in general, our view of roasting is that conduction is essentially almost always undesirable in terms of the way we roast. There's a kind of long-standing theory that conduction gives you more body, for example, in your roasting and more of those caramelized flavors. But I think if you manipulate your roast profile in a convection roaster, you can achieve the same body, you can achieve those same caramelized flavors that you do in a more conventional drum roaster by using, perhaps higher temperatures or faster roast times or whatever it is that kind of gives you that caramelization you need. But then you also, being convection based, have access to a whole other range of kinds of profiles that drum roasters just can't do whatsoever. So like philosophically for us, we aim to avoid conduction. So yeah, it is possible to, in some ways, to manipulate that, but it's not something we have really thought out.
Thank you. I did miss that one.
People disagree with me on this, though. So that's I would say that's more like my personal opinion than necessarily gospel truth. And I'm sure I'm sure for people that are used to working with drum roasters, they would have different ideas.
Different roasters, different preferences on machines and roasting styles. So it's, we all have different opinions. Let's see, there's a question here. How fast does the drum material respond to temperature changes?
Okay. I'm not sure how to answer that question in a way that that makes sense. But here's what I'm going to do. So right now it's cold. I'm going to fire it up, and we can watch a little bit in real time. By the way, the fact that the roaster is room temperature right now tells you just how quick it is to cool down and heat up. So we go into live view. Okay, so I've started a batch, and we're starting at room temperature. So now we can watch how the different temperatures respond to that heat input. And if I'm trying to get the roaster warmed up in the morning, I would normally charge a batch and then crank the power up to full so that it stays on full in manual mode. So now we're heating as fast as we can. And if you look at this, the purple line on the bottom, that is the drum surface. So you can see that is, of course, that is the slowest one to respond, but it's starting to climb up already. So yeah, in terms of like how fast in degrees per second, that really depends on your airflow, what temperature it currently is, what temperature that your air is at. But you can see the heating up process is not super slow. We're started at 25, we're up at 50. Heating up the roaster to working temperature is, something that takes less than 20 minutes. Never actually really tried to measure. I basically just crank it up to full, wait till the drum temperature reaches 150, and then go to idle. It doesn't take very long. Yeah, that's maybe the most truthful but least useful answer to that question. So we can watch it while we respond to any other questions, if there are any others.
I don't think we've got any more questions in the chat, but it's great to see the in real time how the roaster does heat up. So you could be preheating the roaster to your target temperature whilst you finish weighing out your green beans, getting the last bit of admin before you start roasting, but also maybe just finishing that cup of coffee so that you are fully aware and caffeinated before going into your roasting session.
Yeah, and I think the key thing for us here is the drum is deliberately designed not to take a lot of heat and not to give a lot of heat to the roasting process. So it's stainless steel, which has a lower heat capacity anyway than cast iron, so it absorbs less heat for a given temperature, and that means it then gives less heat to the beans. It's also quite relatively thin. Because the drum isn't rotating, it doesn't need to be a thick wall. So we've got these thin walls that are steel. They don't hold a lot of heat, so they have a quite minimal impact on the roasting process. So if you want to start your roast from cold, you absolutely can. That in no way is going to result in a bad roast. The only reason that we preheat the drum to a specific temperature is for consistency. And the easiest way to be consistent is to start hot, because if you start every roast cold, then you've got to cool down the roast every time. But if you just need to fire it up, roast a batch really quickly, and maybe it's a coffee you haven't roasted before, so consistency isn't even a question. There's nothing to stop you from roasting cold. The cold drum doesn't cause major problems for the roast. So that's something that's really different on a drum roaster. If you try and roast from a cold drum, that coffee is going to be ruined.
Thank you, Tom. All right, I think we're about ready to wrap this session up. So I did just want to drop in some information for those of you who are still looking for information. So in the chat there's a link to the information on our sample roasters. The one that Tom has shared with us today is the L100 Plus, which is our top model. And we do have 3 models, so the S100, the S100 Plus, and the L100 Plus. So have a look, compare the different features, because each sample roaster has different number of sensors or different features, and choose the best one that is for you. If you do have any questions or you want support on trying to choose the best roaster for you, we've got a blog post where we compare the S100 Plus and the L100 Plus, but also our sales team are on hand. So if you have any questions, please contact our sales team. Their email address is in the chat there. So sales@roastcoffee.com. But also Tom and his team are on hand to answer your questions, whether it's to help you create a profile or you have an issue or technical difficulties with your machine. We are here to help. So for today, this webinar has been recorded. I will email out a link to the recording so you can watch back. And if there's anything that you wanted to check back on, that'll be available to you. But also we are offering free shipping and through to the 25th of September. If you're ready to make your purchase and join the ROEST community, and that discount code will be in that email for you as well. So we're here. Contact us, get in touch. I'm on Instagram. You've got the sales email there. We are here to help. So if you can't think of any other questions now, feel free to get in touch. But thank you for joining us today. We appreciate you taking the time out to watch our demonstration and participate in this Q&A session. So thank you very much, Tom, for that demonstration. And
thank you, Kimberly. And just to keep banging on about the drum temperature, it already reached 160 by the time Kimberly started her closing speech. So in terms of the heat up time, that is how fast it can be. Normally, I would now let it sit for a little while at idle so that heat can stabilize. But just to give you an idea of quite how fast that is. Anyway, I will stop now. Thank you guys very much for coming along. And thank you, Kimberly, for the questions. And thank you to Joe, who's been doing all of the technical side of these webinars. He's shy to show his face, but we couldn't have done it for him. So yeah, thanks everyone.
Thank you, and we'll see you on the internet. Bye for now.